Hello, Dr. Ekker. Creativity and out-of-the-box thinking, serendipity and chance, they all play a part in scientific discovery. Have they shaped the field of genome engineering?
Oh, yeah, absolutely. The Nobel Prize for CRISPR really represents this. Much of the initial evidence for the CRISPR system came out of sequence gazing of bacterial genomes and wondering what these sequence repeats are that could be functional. And then another scientist understanding how the bacterial genomes have evolved, where those sequence repeats would change in different bacterial species over time or within the same species over time. So I think most of the technologies that we're doing in the genome engineering field was based on some initial observations and then scientists putting them in context and then figuring out how they can be used as a novel tool. And that sort of cycle goes back to the initial restriction enzyme from many years ago to the custom restriction enzymes that were zinc finger nucleases, and then these more programmable systems called the CRISPR systems. In all of those cases, all those tools, transposon tools, viruses used for gene therapy, all of those are endogenous systems that have been coupled and correct. But I'm excited by the combination of synthetic biology, where you take engineering principles and you say, well, I don't have this tool, and I don't seem to find it in Mother Nature. Can I build it from scratch? And it's when you take this initial stage of sort of taking the natural products and then figuring out how to harness them. And then the next wave, which is building new products that don't exist. Example, I would argue that base editors are products that actually don't, although components all exist, they're putting them together. But those were completely de novo. So I think we have a whole series of these kinds of products ahead of us that are going to be new tools that are going to allow us to do things we can't even imagine today. So I think we've got this really interesting scenario where you've got actually arguably in the genome engineering 2 Nobel Prizes. The initial Nobel Prize of the EcoR1 restriction enzyme, and then we have the CRISPR Nobel Prize, and which is really programmable restriction enzymes. It's going to be exciting to see what the next prize is in the field, because there's going to be a next prize. I have no idea when it's going to be, because I think that's what serendipity is scenario. But I think that we've got this really clear sort of path and trajectory of excitement in the future.